Greetings dear students. In this video we will learn a Fortran program to find root of cubic polynomial using bisection method, and I hope you all are familiar with bisection method. Okay, let us start. Let us solve this for a particular polynomial, and we define that polynomial using a statement function. Let it be fx is equal to x cube minus 2x minus 5. Now we read initial approximations x0 and x1 along with error tolerance, and then we will write the loop while this condition is true. And what is that condition? Absolute value of consecutive iterations is greater than error, and then we perform the iteration. First iteration, x2 is equal to x0 plus x1 divided by 2.0, and then we will see where the root lies now. For that we will check the sign of the function. If fx1 into fx2 less than 0.0, then very clearly if fx1 fx2 is less than 0, that means root lies in x1 x2, so x0 will be replaced with x2, and in the else part root lies in x0 and x2, so then x1 will be replaced with x2. Then we will write, and if can continue, and then we will print the root. Once this process is over, we will print the final answer, that is x2 read star stop. And before executing, let me make the first line as comment, and now let me save this, compile and execute. And here the initial approximations are 2 and 3, and allowed tolerance is this, so this will be the answer. This will be the answer. Okay, let us check how many iterations are performed. To check that, let us take a counter I is equal to 0 initially. Then after the one iteration is over, we will add 1 to it, and let me print here print star comma total iterations performed is equal to I, and here we will print root is equal to. So let us see how it can change the presentation. So again 2 3 0 0 1. So as you see, after 10 iterations we will get this answer. Okay, let us make it more interactive. How can we make it more interactive? Just have a look. So we will print answer of every iteration. Let us see how that can be done. If we write a print statement here, and let me write iteration number I. Okay, let me write it in commas, then comma I, again root is x2. Okay, let us now see how this will affect the program. Okay, let me enter 2 3 0 0 1. Just have a look what we get now. Just have a look. First iteration, second iteration, third iteration. As you see, after 10 iteration, you see the difference. When the difference is less than 0.001, that is the final answer, 2.094. You can even increase the number of decimal places for which accuracy is desired. Okay, let us move further. Let us make this program journal. Journal means, as you see, this is for a particular equation. If we want to make this program for a journal cubic, let it be ax cube plus bx square plus cx plus d. So for this, we have to enter the coefficients, print star comma, enter values of a, b, c and d. Let us read those values, a, b, c, d. So similarly we will print here, print star comma, enter initial approximations and error tolerance. As we have to call this function with values a, b, c, d, so we have to enter here a, b, c and d. Similarly here a, b, c and d. Similarly here a, b, c, d and x2. So as the coefficients are integers, we can declare integer a, b, c and d. Let us save this. Now let me compile this. So it was compiled. Now let us run and enter the coefficients. Let me enter the same coefficients: 1, 0, -2, -5. Error and initial approximation 2, 3, 0, 0, 1. So on your screen, as you see, we will have same answers. That means so this will run perfectly. I hope you got an idea how we can write a program for a particular equation as well as for a journal equation.